I looked everywhere for a backtester built for prop firm rules. GitHub, 0 results. Google, one tool that does it, and it isn't even out yet. And when it is out, it'll cost money. So I turned to Old Faithful, Claude, and it worked until it didn't. I quickly burned through all my tokens, and even when it ran, I couldn't see inside. Just results, no reasoning, a total black box. So there was really only one option left, build the backtester myself. But the problem is, I don't know how to code. And if I mess this up, I have no real way of telling if my strategies would get me a payout or completely blow up the account. Let's quickly catch up to speed of what we did in last week's video. Looking to get payouts from prop firms, we threw out the one master strategy approach, and instead changed to one strategy for the evaluation stage and one strategy for the funded stage. Each of those strategies had a couple different strategies baked into them, and then the risk levels were tweaked to optimize for the different requirements of the different stages. Wanting to see how those strategies would have performed if they were deployed in a real prop firm challenge, I gave the CSV trade log of each strategy of a 3-year backtest to Claude. I had Claude run the analysis with these rules. These are for a Topstep 50K funded account. These were the assumptions made for the analysis. This was the results for the evaluation stage. Negative expected value, but very high win rate. That's exactly what we were shooting for. A little bit of a different story with the funded stage strategy. We accidentally did have positive expected value, but the win rate was way too low. So what were the results from Claude's analysis? Over those 3 years, the revenue would have been $48,000, expenses $14,000, net profit $33,000. That's if you were just using one Topstep 50K funded strategy, deploying the eval strategy in the eval stage and the funded strategy in the funded stage. But those results weren't good enough for me, and I needed to upgrade the strategies. This is where using Claude for the analysis of the backtests first started to show its weaknesses. I'll get to that in a second. First, let's really quickly look at the upgrades. So the eval strategy was still using mini contracts, 5 of them on a 15-minute time frame. And after the upgrades, we were able to bump up that win rate up to 92%. Again, barely positive expected value, but not really what we're focusing on. For the funded stage upgrades, actually moved over to using micro contracts, 10 of them on a 30-minute time frame. And we were able to get that win rate up to 83% while keeping drawdowns very low. But I couldn't just go back to Claude and rerun the analysis. As we can see here, it was 35 months of data, about 3 years, and combined close to 7,000 trades that Claude had to process. My tokens were gone instantly. I hit my usage limits for the day. That was the first issue I ran into, and the first reason why I knew I needed to build my own backtesting environment for prop firm rules. But it doesn't stop there. If I just kept improving the strategy and giving it back to Claude and getting the results back, I was just going to overfit to the data, because I couldn't see into what was actually going on in the different trading events. I could just see the final results. So that brings me to my third issue. Using Claude to analyze the backtests is a black box. I can't see behind the curtain to what's actually going on. I can just see the final results. If I want to tweak different aspects of it, use different rules for a different challenge, look at one specific trade and why it blew up, I can't go in and see Claude's analysis. But when I build my own backtester, each one of these files is mine. I can tweak any little rule, and I can see every event that happened to make up the results. So if I don't build my own backtesting environment and I keep using Claude, I'm going to run out of tokens immediately, I'm going to overfit to the data, and I'm not going to be able to actually see what the analysis is. So I clearly need a repeatable backtesting environment. So let me just go find one. Well, that brings me to the fourth reason why I need to build my own backtesting environment, and the whole reason for this video. There isn't one out there. Now don't get me wrong, there are plenty of free backtesting softwares out there, but I don't need just any backtesting software. I need one that backtests specifically against prop firm rules, and can do so using different strategies for the eval and funded stage. That's what's not out there. I first looked on GitHub. That would be ideal, because if I could just get the code for one, I could tweak it to my needs. But there were somehow 0 results. So I then just went to Google. And at first I thought I saw promising signs, but most were just this. They were a comparison tool comparing different prop firms, which is useful, but not what I needed right now. Now this first one was very promising. That's what we see over here. Simulated prop firm eval, build and backtest trading strategies. That's exactly what I need. But it doesn't even exist yet. That's what this is, get early access. It's not even out yet. And then once it is out, it'll cost money. So all this led me to the super easy decision. I needed to build my own backtesting environment for prop firm strategies. Okay, great, I know what to do, but now how am I going to do it? Well, once we break it down, it actually doesn't look too bad. First step is setup. Set up a Git repo and connect it to VS Code. This is where all the files are going to be stored. Second, define all the prop firm rules. The rules that we were looking at here, just need to put them into a language that the algorithm can actually understand. Next, import the trading logs from TradingView. Now this is a little different than most backtesters that people build. Most people actually run the backtests in their backtesting model. Now the reason I'm not doing that is I already pay for data through TradingView. So I have access to a lot of solid quality data, and TradingView will just run the backtest for me. I pay for it, might as well use it. What TradingView won't do is run it against prop firm rules, simulate different phases, switching from one to the other, calculating the reset fees, the payouts, the consistency rules, all that. So that's why I'm building this model. Then building a trading model. So what this is doing is just taking the trading log and translating it into a language that the model understands. Next, build an account state model. So account state just means, is it in an eval state or is it in a funded state? Actually, much more complicated than anticipated, because you have a lot of different ways that you can move states. You can blow the account, which is the most obvious. You can fail the eval or you can blow the funded. Each of those have different rules though. You can pass an eval to get to a funded, and you can get a payout from a funded account to then, which then needs to be recorded, but there's multiple different ways that you can get a payout. And then how does that affect the max drawdown? And then when the account is blown, back to the eval. There's a lot of contingencies. So then next, build the prop firm rules engine. So here we define the prop firm rules, but now they actually have to be enforced now that we know the different account states and we know what the different trades are. So once we can enforce rules on account states that we know, on trades that we know, we can build the historical simulator. So this just does all of it in a chronological order of just this happens, which causes this, then this happens. Took this trade, account equity goes up to here. That means trailing drawdown goes up to here. That means we're this much closer to a payout. That means we blew the account. Okay, so then reset, mark the reset fee, take another trade. Essentially just walking through every step of what would happen in the history of the backtest. Then lastly, validate that it works, run the simulation, look at the results. So that is part 1 of this prop firm backtester, just the backtesting part. That is what we did this week. Next week, we're going to do this next part, part 2, which is the forward testing on synthetic data with Monte Carlo simulations. So that's just a little sneak peek for what's to come. The model isn't actually fully done yet, but the backtesting portion is. Okay, so now let's go through the important parts of each step of how the model was actually built. So first, very boring, the data loader. All this is doing is just pretty much telling the model, hey, go ahead and take a look at these trading CSVs. That's what we're going to be looking at. That's what we're going to be using. Just at some point, we have to tell the model to do that. And that's all this is doing. All right, so then we have to build the trade model. What this does is define the data shapes. So what are the objects that the simulator is using? For example, what does quantity mean? What does entry price mean? What does P&L mean? We know what these mean, but we have to tell the model what it means in context, where to find it. And then, like I mentioned, the account state logic is in here as well, that we went over, of just what is the current conditions of the account. Is it blown? Is it an eval? Is it unfunded? Etc. Now this file is supposed to be clean, and it better be right, because essentially all the other files rely on this. If you keep referencing entry price, for example, but the model doesn't know what entry price is, everything down the line is going to be wrong. Okay, so next is the rules markdown file. So this is actually really cool in that it's written in English, but you actually can tweak stuff here. And then this rules file written in Python is where the simulator looks when trying to enforce the rules. Hey, what are the rules? It looks here. If these look familiar, it is exactly the rules of a Topstep 50K funded challenge. Then had to build the simulator. This is what actually enforces the rules. And so it takes 2 trade streams: eval trades, the strategy used during evaluation, and funded trades, the strategy used during the funded stage. So it starts running through eval trades until either you pass or fail. If you pass, it switches to the funded mode and starts applying those rules. If you fail, it logs the reset fee, resets the account, and starts a new eval run. It keeps looping through this cycle until it runs out of trades, and then produces a full event log and the rest of the results at the end. What are those trades that it's looping through? The CSVs from the TradingView backtests. So as you can see, there is a lot of data that's actually tracked in these trade logs, and we use pretty much all of it. As you can see though, this would be terrible to do by hand. I have a filter, I don't know what you call it, that makes the different rows of the CSV different colors, but it still is way too much to look at. So shout out Python, shout out technology. And then yeah, funded trades, same thing, same timeline, just a different strategy. Then the results actually get put into a separate folder, so they're easy to keep track of. And that happens when the simulator is ran. So that's actually under tests here. This test, run historical sim, runs the simulator file, and then it puts all the results into the correct place and prints them out in the terminal as well. All right, so speaking of the results, what were they? Well, something key to note, building this backtester, it actually caught something that I completely overlooked when previously building these strategies. The results weren't actually as good as I showed before. And that's because I completely overlooked the fact that an unrealized loss still counted if it hit your max drawdown. You'd be instantly exited and the account would be blown. And now I knew that, but for some reason it didn't get into my code. I had just completely overlooked it when writing the strategies. Even looking at the trading logs, see like, okay, loss of 3,500, yep, that would have blown the account. All right, win of 500. But what I had completely disregarded was the trades that unrealized went past max drawdown and then came back up to a profit, which wasn't many, but definitely a significant amount. Like, it tangibly changes the results. And it does so because I was shooting for big losses due to the asymmetric risk profile that I was talking about in the past couple videos. If you're going to lose, you might as well lose big, because all you're paying is the reset fee. You're not paying the actual loss. But you can't actually lose that big. You can't lose more than the max drawdown, because you can't go past it. Your position will get exited and the account will be blown. So not a huge deal, but definitely good that the backtester was able to catch it. I was looking at the rules file and I saw some logic in it that for some reason made it click for me of if realized or unrealized trade hits max drawdown, account blown, which there are even no unrealized trades in the backtest log because it's a backtest, they're all in the past. But that made it click, oh, I completely forgot about that. So I implemented it back into the strategy. It honestly barely changed the funded account one, but it did make the eval strategy much worse. Basically back to where it originally was, because it originally was fine. I upgraded it, but then after adding in the unrealized blowing the account, it went back to basically where it originally was. All right, but let's get back to the results. So first file it creates is an equity curve. As you can see, this doesn't look like much of a curve right now because obviously it's not. I haven't added the visuals yet. That's going to come later. As we can see, that's step 12 that we haven't quite got to yet, add visuals. But this will be the data that does build that equity curve. Right now, there's really nothing to look at. So next is the events file. Now, just reading through this wouldn't make any sense, but what it is really helpful for is if you're wondering why something happened. This is how we can metaphorically see into the black box, like I was wondering about earlier. If I'm wondering, wait, why was the account blown then? What happened? That doesn't seem right. I can go back and see every event. Trade here, violation, trade, reset, trade. You know, I can see, okay, violation of consistency rule, reset, fee, $85. So this is helpful to go back, check a date, check a time, what happened, why did it happen? Actually crucial. This is similar, but just a little bit more zoomed out, looking at each of the runs. Here we can see we had immediate violation here, the daily drawdown limit of 1,000, so that was blown. Here we can see we got payout through the consistency rule. Here passed an eval for the reason ready to switch, so the profit target was hit. So again, just a little bit more zoomed out, seeing what happened on the different runs. Then the slide that everybody wants, the actual numbers, the results. Personally, I'm not too curious about this right now because I'm not even sure if this model is 100% accurate. Like, it works, it runs, which it didn't for a while, it took me a bunch of tweaking. But I do have to go back and check some of the rules, so I can't look at these numbers 100%. They look pretty reasonable though. So over 3 years, there was 478 runs, passed the challenge 52 times, failed it 289 times. That does make sense because our eval strategy got nerfed so hard after fixing the unrealized gains. But then we can see number of payouts 84, number of blows of a funded account 52. This also makes sense. Our funded account barely got nerfed by the unrealized payouts thing, and we improved it a ton. So now we are getting a payout more often than we're blowing an account once it gets to funded. We definitely have to improve that eval strategy though. Still, that's so many reset fees. Total revenue and expenses, those numbers seem really high. I guess it does make sense. The strategies are higher frequency than the last time I ran the analysis. But we're looking at 260,000 for revenue. Over 3 years, not that crazy because it's running constantly. But it is only one 50K account, so payout is like 600 to maybe 1,500. So if we're looking at 84 payouts, 270,000 divided by 84, that's an average of about 3,200 per payout, which might be right. It seems a little high, but I don't know. This is why I have to go back and actually check what's really going on, make sure it's all accurate. But great start. The model actually runs. Very happy with that. From here, it's just making sure it runs accurately And then we can just iterate, new strategy, just keep testing them, keep getting better. But we're going to run into the issue of overfitting. If we just keep improving the strategies over the same data, we're just going to be backfitting to that data. So that's why we're building the second part of the model, forward testing, testing on future data, synthetic data, running Monte Carlos without resampling, which is just shuffling the trades, and then with resampling, which is shuffling them and taking some trades multiple times to see all the potential variations that we could have. So that's the big goal for next week. Finish this model, make it more accurate, add the forward testing. Very excited to get to that. Honestly, can't wait. This is definitely getting exciting, seeing a lot of progress. As always, thank you for watching. This is purely a journal. I am in no way an expert, and this is definitely not advice.